Okay, so one experiment we wanted to show for the pMOS VI characteristics also, just so that we complete this thing. So new cell view and create new pMOS VI and insert. So I want to start with GPDK180 and pMOS transistor. Size doesn't matter. Okay, and just like the previous case, along with that, two voltage supplies are required. So one I will keep here and one I will keep here. Okay, and one or more ground terminals. I will put one ground here for now. Okay, so and just like the last time, the gate voltage is a variable VG, we will call it. Okay, and we are going to vary this through a parametric analysis, just like we did for the NMOS transistor. And rest of the circuit, only this much is there is nothing else. Okay, but only problem is how do we get the characteristics. So we have to remember a few things. Okay, so this is a transistor, pMOS transistor. If you click on this terminal, okay, it's become pink color. It's called G, that is for gate. Okay, the top is source and the bottom is drain, and this is fixed in this simulator. Even though theoretically source and drain are interchangeable in most circuits, even in practical circuits, okay, one will always be acting as source and one will always be acting as drain. And in the simulator also, for the sake of naming, because we cannot, simulator cannot automatically decide, they have fixed this terminal with the arrow mark is always the source terminal. Okay, and for a PMOS transistor, if you remember the VI characteristics, it is in the third quadrant, meaning that both the VDS and the VGS both have to be negative numbers, otherwise current will not flow. So what we have to do is we have to set up this circuit in that way. We have to set it up such that the source voltage, okay, and sorry, the VDS and the VGS, wherever we are giving them, they are always in the negative range. So how do we do that? So we can do that by, what we are going to do is we are going to put this voltage source here. Okay, and I will put this to ground, or I'll just separate this little bit for now. And what I'm going to do is I'm going to connect the source terminal, okay, permanently to ground. Okay, you see this thing here, source terminal is permanently connected to ground. So now suppose I put some value here. Okay, VD, for example, if it is 2 volts, then VDS will become 2 minus 0 is plus 2 volts. So I don't want that, right? I want only negative values for VDS, and the same thing for VGS also. Now one side I am connecting to ground. Okay, so that is fine, and the other side I am giving to the gate terminal, and this is the connection. Okay, so one mistake, I am not connected to fourth terminal. Okay, now this is my circuit, and I do check and say there's no problems. Now how can we guarantee that VGS and VDS, okay, are always negative values? So what we are going to do is, when we are doing the analysis, that is the DC analysis and the parametric analysis, we are going to make these values of these two sources start at 0 just like before, but instead of going in the positive direction, you make them go in the negative direction. Okay, so 0 to minus 2. So when it is 0, for example, VDS equal to 0, when this becomes minus zero point 0.5, VDS becomes minus zero point 0.5, and when it is minus 1, it also becomes minus 1, and so on. And the same thing here, because this terminal is connected to source. See the connection here. Okay, see, it's connected to source through this wire. So whatever coming here, if I keep making it come as negative values, then automatically VGS will become negative values. So that way we can make sure that we are giving only negative values for both VGS and VDS. So once we know that, then the rest is the same. Launch ADEL, okay. Variables, copy from cell view, so the VG will come. Analysis, choose, okay, we want a DC analysis and we want to change a component parameter. Select component. Again, remember this is for the DC analysis because this is VDS, okay, and click on DC voltage because that is the parameter we want to vary, and start at 0 and go to minus, go to the negative range and say okay. And then here we have outputs to be plotted. Select on design, I will choose the current, and that's all the options we have to give here. Then for the parametric analysis, we go to the tools, parametric analysis, and we have to get the design variable which is VG, and here also start it at 0 and go to negative 2 volts, and that's all we have to do for the simulation. And you see that all of them are coming like this, and this is basically your VI characteristic of the pMOS transistor. And the only difference between NMOS and pMOS is in NMOS VDS starts from 0 to +2, pMOS it goes to 0 to -2. And there might be another way. This is just one way, this is not a unique way to create a circuit, this is just one way. If you find any other way to set it up so that the VGS values goes from 0 to -2, that is also perfectly fine, okay. So this is the VI characteristics of the pMOS transistor. So if you want it to come in the third quadrant, we will see if we can try that. Basically it's just a matter of nomenclature. Delete this, and outputs to be plotted, I will select this one, and then everything else is the same, okay. So it is still coming as a positive current, no problem, that's fine, okay. I just wanted to see if we can get a negative current, but in both ways it is not coming as a negative current, that's fine, no problem, okay. So this much if you do, we can get the VI characteristics of the pMOS transistor, okay. Thank you.